Okay, so get ready because today we are going deep, deep into the world of parallel universes.
Yeah.
We got this thesis on multiverse theory, and wow, it's a wild ride.
It really dives deep. It's not just like, hey, multiverses exist. It's like, here's how they work, here's why we should care. It really breaks it all down from the different types of multiverses to the actual science behind them.
Right, and the implications of it all. Like,
Yeah.
are there infinite versions of ourselves out there? The thesis really makes you think about stuff like that.
Totally. And it starts by, setting the stage, reminding us how mind-blowingly huge our universe already is. It's like we've got billions of galaxies, and that might just be the tip of the iceberg.
It's crazy to think about. But then it goes even further, suggesting our universe might not be the only one, which is where the multiverse comes in.
Yeah. And it's not even a new idea. The thesis actually traces it back, talking about ancient philosophers like Democritus, who were already thinking about other worlds way before modern science.
It's amazing how long humans have been fascinated by this stuff. But it wasn't until the 20th century, with things like quantum mechanics and relativity, that the multiverse really started to be taken seriously by scientists.
Exactly. Those discoveries in physics, our understanding of the Big Bang, it really opened up new ways to explore the idea.
It's like those early philosophical questions kind of laid the groundwork for today's scientific exploration. So, about those different types of multiverses, the thesis breaks them down into four main categories, right? Let's start with bubble universes.
Okay, so imagine like a pot of water simmering. Now picture it boiling over, creating those bubbles, each unique, those are your universes. That's kind of the basic idea behind bubble universes, stemming from this theory called eternal inflation.
Okay, so instead of inflation stopping after the Big Bang, it just keeps going in different parts of space-time, making all these bubble universes. Am I getting that right?
You got it. And each of those bubble universes could have its own unique set of physical laws, like a universe with different gravity, maybe light travels faster there. The possibilities are endless, really.
Whoa. Okay, that's a lot to process.
Hmm.
So we've got bubble universes popping up everywhere. What about the quantum multiverse? That one always messes with my head.
Right. This one is where things get really wild. Have you ever, made a decision and then thought, man, what if I had done something differently?
All the time.
Well, the quantum multiverse basically says every choice you make, every possible outcome actually happens, but in a separate universe.
So there's a universe where I actually became a doctor like my mom wanted, instead of, doing this.
Could be. Maybe you're an astronaut in another, or a chef, or even a rock star. It's called the many worlds interpretation, and it suggests that every possibility, no matter how strange, is playing out somewhere.
Whoa. It's both exciting and kind of terrifying, right? Okay, on to the next type of multiverse before I freak out. Brain worlds. What are those?
This one's tough to picture. Think of our universe as like a slice of bread, a brain floating in a much bigger loaf. That loaf is a higher dimensional space.
Okay, so other universes could be existing right next to ours, but in different dimensions, totally invisible to us.
Exactly. We wouldn't even know they're there. It's a concept from string theory, which basically says there are more dimensions than the three we can see.
Wait, so string theory, which is all about tiny vibrating strings,
Mm-hmm.
is saying those strings could be vibrating in dimensions we can't even see, creating whole other universes right next door.
That's the idea. And the thesis explains how those universes might even interact with each other through gravity, which is pretty cool.
It's mind-blowing.
Yeah.
Okay, last one. Mathematical universes. That sounds like something straight out of science fiction.
It kind of is. So imagine that every mathematical structure, every equation corresponds to a real physical universe out there.
So, if you could describe it with math, it exists. That's a wild concept.
It is. This theory, and it was really championed by physicist Max Tegmark, suggests our universe is just one tiny piece of a huge mathematically defined multiverse.
Okay, I need a minute to process all this. Bubble universes, quantum multiverses, brain worlds, mathematical universe, it's a lot. But how does science actually support any of this? That's what I really want to know.
That's the million-dollar question, and it's what we'll unpack in the next part of our deep dive. Welcome back, everyone. Last time, we were talking about all these different types of multiverses, bubble universes, quantum multiverses, you name it. But we left off with the big question. What does science actually say about all this?
Right, because it's one thing to imagine these wild possibilities, but does any of it actually hold water, scientifically speaking? This thesis does a good job of going beyond just the what-ifs and digging into the actual science behind these mind-blowing ideas. So, where do we start? I know the thesis talks about cosmic inflation as a big piece of this puzzle, right?
It's huge. Cosmic inflation, this idea that the universe expanded like crazy right after the Big Bang, it really sets the stage for the idea of bubble universes.
Okay, so walk us through that. How does cosmic inflation lead to the idea of multiple universes bubbling up? I'm trying to picture it.
All right, imagine the early universe like a balloon, right? And it's inflating super fast. Now, within that rapid expansion, some regions might inflate a bit differently, creating these little pockets that kind of pinch off from the main balloon. Those pockets become your bubble universes. Each one is like its own little Big Bang on its own unique path.
So each of these bubble universes would essentially have its own set of starting conditions, its own rules, its own unique way of evolving.
You got it. And even small differences in those starting conditions, like a slight change in the strength of gravity, could create universes that are radically different from our own.
It's wild. And this is where cosmic inflation, as an actual scientific theory, starts to make the multiverse idea seem a little less out there. It's like a plausible mechanism for how those other universes could have formed.
Exactly. It gives it a framework, you know?
Okay.
Okay, now let's jump to another big concept, string theory. You know how we think of ourselves as living in a three-dimensional universe? Up, down, left, right, forward, back.
Yep, that's how we experience the world. 3 dimensions. Makes sense to me.
Right. But string theory says, hold on a second. What if there are way more dimensions than that? Maybe 10, maybe 11.
Whoa. Okay, now you're just messing with me.
Hey,
How can there be more than 3 dimensions? That's blowing my mind a little bit.
I know, it's a tough one to wrap your head around. Think of it like this. Imagine a garden hose, right? From far away, it looks like a one-dimensional line. But get closer and you see it has this whole other dimension, this curved surface. String theory says our universe might be kind of like that, with extra dimensions curled up so small we can't see them.
Okay, I think I'm starting to get it. But how does this tie back into the multiverse?
So these extra dimensions, even though they're hidden from us, they could be where other universes are hiding. Remember that slice of bread analogy? Our universe might be just one slice or brain floating in a much bigger loaf. Other universes could be right next to us, separated by these tiny, curled-up dimensions that we can't even perceive.
So we can be totally surrounded by these other universes, and we wouldn't even know it because they exist in these dimensions we can't access.
Yeah,
That's both amazing and kind of creepy.
it is. And it all stems from string theory, which is one of the leading contenders for a unified theory of physics, which is pretty mind-blowing in itself.
Seriously. It's incredible how these complex theories can have such huge implications. Okay, so we've got cosmic inflation and string theory, both offering potential support for the multiverse. What about quantum mechanics? How does that play into all of this?
Quantum mechanics. This is where things get really strange, even by multiverse standards. Remember the many worlds interpretation we talked about earlier? That comes straight out of the weird and wonderful world of quantum mechanics.
Right, the many worlds interpretation. Basically, every quantum event, every possible outcome, it all happens, but in different universes. Reality is constantly branching off, creating new timelines for every single possibility.
Exactly. It all comes down to the idea that in the quantum realm, particles exist in this fuzzy state of possibilities until they're observed. It's like they're in multiple states at once.
Like that poor cat, Schrödinger's cat.
Yeah.
Both alive and dead, until somebody opens the box and looks inside.
Yes, Schrödinger's cat. A classic example of just how strange quantum superposition is. And the many worlds interpretation takes it a step further, saying both outcomes, the cat being alive, the cat being, well, not alive, actually happened, but in separate universes.
Okay, that's both hilarious and kind of disturbing. But it does make this really abstract concept a bit easier to grasp, at least for me. So we've got cosmic inflation, string theory, and quantum mechanics, all kind of hinting at the possibilities of multiverse. But the big question is, if these other universes are out there, is there any way to actually prove it? Or is this all just fascinating speculation?
That's the million-dollar question, and it's something scientists and philosophers are really grappling with. It's not an easy one to answer.
I bet. We're talking about something that's potentially beyond our ability to directly observe, right? So where do we even start looking for evidence?
That's the challenge, and that's what we'll dive into in the final part of our deep dive.
So we've spent all this time talking about the mind-blowing possibility of a multiverse with all these different types of universes out there. But how could we ever actually prove it? It seems like a long shot, right?
It is a huge question, and it's something that this thesis really grapples with. It acknowledges that we're dealing with concepts that are, well, right at the edge of what we can observe, even with our most advanced technology.
Right. It's like we're trying to find a needle in a cosmic haystack. Where do you even begin to look for evidence of something that might be fundamentally beyond our reach?
Well, scientists have come up with some pretty clever ideas. One thought is to look for these tiny variations in the cosmic microwave background radiation.
You mean like anomalies in the oldest light in the universe, something that might hint at interactions with other universes?
Exactly. Imagine our universe as a ship, and it's sailing through this vast cosmic sea. If another universe bumped into ours, it might leave these subtle ripples or patterns in the cosmic microwave background, like the wake of another ship. Detecting those patterns could be a sign that, yeah, we might have collided with something, cosmically speaking.
That's such a cool way to think about it, like cosmic bruises from bumping into our universal neighbors. Are there any other ways we might be able to indirectly detect these hidden universes?
Some scientists believe that strange behavior of gravity could be a clue. The idea is that if other universes are out there, relatively close to ours, their gravitational pull might have a subtle influence on how matter behaves in our own universe.
So we might not be able to see these other universes directly, but we could potentially detect their presence by looking at how gravity works in our own cosmic backyard. That's fascinating.
It is. But even these indirect methods, they're still incredibly difficult. We're talking about trying to pick up incredibly faint signals against a very noisy background.
It's like trying to hear a whisper in the middle of a hurricane. It sounds like we're going to need some serious advancements in technology before we can even attempt these kinds of observations.
Yeah, it might be a while. But even if we never definitively prove the multiverse is real, just the process of exploring these ideas, it really pushes the limits of human knowledge and our imagination.
Totally. This whole deep dive has really sent my mind spinning. But I like how this thesis doesn't shy away from the philosophical side of things either. If there are all these other versions of ourselves out there, what does that mean for us?
It's a huge question, right? It makes you question everything. Like, if there are infinite versions of you out there making every possible choice, does that mean our choices don't really matter? Or does it mean that everything we do has infinite possibilities?
I don't know the answer, but it's a lot to think about. It's kind of freeing, though, in a way, right? The idea that there's no one right path, that everything is playing out in some version of reality.
It really is. And what about the meaning of life? If the multiverse is real, does that make our search for meaning pointless? Or does it make it even more important to create our own meaning in a reality where literally anything is possible?
It's a real head-scratcher.
Hmm.
But I think that's what makes the idea of the multiverse so captivating. It forces us to confront these really big existential questions. It makes us think beyond our limited everyday experience and consider what it really means to exist.
It's a humbling thought. And it reminds us that no matter how much we think we know about the universe, there's always so much more out there to discover.
Absolutely. So while we might never know for sure if those other regions of ourselves are out there, somewhere in the vast expanse of the multiverse, just thinking about the possibility can change how we see ourselves and our place in the cosmos. It's a good reminder to never stop asking those big what-if questions. And on that note, a huge thank you to all of you for joining us on this incredible deep dive into the mind-blowing world of parallel universes. Keep looking up at the stars, and we'll see you next time.